Hello, welcome to Coffee Break with Microchip Technology. Coffee Break is our ongoing forum in which we discuss new and evolving technology, all in about the amount of time it takes to drink a cup of coffee. I'm your host, Eric Glatfelter. If this is your first time joining us, welcome. If you're a repeat viewer, welcome back. This is our 9th season of Coffee Break, hard to believe, but here we are. Also joining us today is our moderator, Aaliyah Fahout. Aaliyah, welcome back.
Thank you, Eric. Welcome back, audience, to Season 9. We are currently live on Facebook, YouTube, and LinkedIn, and you can participate in today's episode by leaving your questions and comments in the chat or emailing us at livestream@microchip.com after the broadcast. Don't forget to follow, like, and subscribe to all our social media platforms. Back to you, Eric.
Thanks, Aaliyah. All right, on to our topic for today, enabling automotive software-defined networks. Joining us today is Daniel Lay, a product marketing manager here at Microchip. Daniel, welcome to the program.
Morning, Eric. Thanks for having me. Good to be here.
All right. So let's frame this a little bit. Let's talk cars. So decades ago, cars were miracles of mechanical engineering, and they're shifting much more to being still a lot of mechanical engineering, but more electronics engineering. And even within that space, lots of hardware, but now even more software. So what is the impact on advanced networking protocols for all the software in the vehicle?
It's been a pretty exciting journey to watch. You know, if you're a car guy, like you said, years ago it was all about an engine and transmission, and now you've got electronics and networks, and makes cars more complicated, difficult to work on, but look at all the features you can get, right? Simple things like your car starts every time, okay, electronic ignition, to the latest thing, electric vehicles, right? And there's this whole gamut of things in the middle that are features and benefits we get from having a car, increased gas mileage, increased safety, and so it's been pretty exciting to watch. But yeah, there's a big impact on the kind of networking protocols and the technologies we've had to support in order to enable those vehicles.
Right. So what exactly is a software-defined network, and what role does that play in a light vehicle?
So software-defined networks, years ago, the big networking guys, the telecommunications guys, realized that they were trying to do more with their networks, but their equipment was all fixed function, right? They really couldn't do more than the piece of equipment was designed to do, because it was very specific. It had a specific function, and things were hard-coded. So software-defined networks was a transition where there was an increased use of general-purpose hardware, but the software determined what the hardware did, okay? So by changing the hardware in the network or on the specific piece of equipment, you could therefore change the function of that equipment or add functionality to that equipment. And what we're seeing in automotive is a general trend in that direction. Current vehicles are much more about fixed function and a fixed module that does one thing, and the OEM buys it from a manufacturer, but we're seeing a trend toward general purpose hardware that does more functions and enables the OEM to load software into the car and add features and functions going forward.
Right. So obviously a very important topic for a design engineer who's designing these systems. Does it impact the consumer directly? I mean, as a driver of the car, is this going to change how I interact with the vehicle?
Absolutely. I mean, let's face it, it's very difficult today to go buy a car that's four tires and a motor and some seats, right? You know, we used to do that, and we used to kick the tires, right? There's still this term, kick the tires, from 50 years ago, when your grandparents would go down and they'd literally see if the tire was, you know, holding air, and then they'd look under the hood and say, oh yeah, it's 8 cylinders, right? You know, cool. Yeah. And then they'd get in the car and drive it away. These days, drivers look at a car and say, is it beautiful? Is it what I want? Does it look the right shape? And then they get inside. They didn't kick the tires, they got inside, right? And they turn the key and they get jazzed about, look at the electronics features. Oh, look at the audio system. Oh, touch screen, right? And so they've got these increased features in a car, and that's what jazzes people. Safety systems jazz people. Think of all the families who are worried about what happens if the car rolls over? What if I get a side impact? You know, things that people didn't think of a long time ago. And so electronic systems change that, and software-defined vehicles would allow the OEMs to offer feature upgrades. You know, you could buy a car and then add features to it, which means you could buy a cheaper car, add features later, or your car might last longer because in fact you could add some features to it. All of us have gone to Google Play or Apple and we take our phone, and whether the phone just came out last month or it came out 2 years ago, we can put a new app on it, right? We can do things we couldn't do before.
Right.
And what you're seeing is automakers are starting to move that way. Okay, you can occasionally get an infotainment upgrade,
Yep.
right? If I go back to, say the Ram dealer and I take my truck in, they'll upgrade, and so now I got a new app on there, right? But it's not comfortable yet, and it's not easy for us as consumers yet, and it requires that the OEMs make some changes in their automotive architecture to be able to support the ability to use software to define the features in the car.
Right. So if I'm hearing you correctly, you get a set of features when you get the car new, but this allows you to upgrade those features or add new features as you go along. So it actually may be more important to you the longer you keep a vehicle, this ability.
Absolutely. I mean, if you're someone who keeps your vehicles a long time, you might be someone who always buys the newest car. In that case, you're always getting the newest thing. But what if you keep your car 2 years, 3 years, 4 years? What if you buy a starter car, right? Your first car you ever owned. My son who just bought his first car, and what if 3 years from now he wants more? Does he have to buy a new car? The answer could be no. He could take advantage of the changes in networking that have already occurred in the car, and we can talk about some of those,
Yeah.
and potentially add capabilities that his car didn't come with initially.
Right. So we are seeing an increase in the number of networking protocols. Lots of cars today now have Ethernet capabilities in them. Does that enable a software-defined network?
So Ethernet is really interesting. Ethernet is a global protocol, right? All the data centers in the world use Ethernet. Most communications infrastructure is connected by Ethernet throughout the world. And Ethernet brings huge benefits, right? It's a standard, it has lots of features, it has high bandwidth, it's got a great ecosystem, right? Every semiconductor guy in the world offers Ethernet products of some kind. Most chips that do intelligent processing connect by Ethernet. So that's a huge benefit to car makers. But it's not the only thing you need. If you're going to do software-defined networking, you need the ability to have general purpose hardware, and you're going to have to provision your hardware to handle heavy duty workloads,
Right.
okay? So what the data center guys have found over the years is that the basic connection between facilities or connection between racks or modules is often done with Ethernet, and anything that's distance, call it diverse data over distance, right? Really, that's an Ethernet function. But when you're talking about heavy-duty workload processing, you're going to need the other data center technology, and that's PCIe. Okay? And PCIe is really designed for interprocessor connectivity. It's designed to enable processors to share data between them in a very fast and highly efficient way, and it brings some benefits to big data processing that Ethernet is not actually optimized for.
Okay. So, and when we talk about, high density data, we're, one obvious example would be imaging data, right? And we're seeing, a camera that is not only the individual camera is now creating and processing more and more data, but, the number of cameras. So you
Right.
get that multiplier effect where you're going from one rear view camera,
Absolutely.
low density rear view camera, to 10 or 12 or 16 very high density cameras looking in every direction.
Absolutely. I was trying to explain this to someone recently, why do I need PCIe, when my backup camera is fine, right? It already works. What do I need some new protocol in the car for? And the analogy I used was Ethernet's kind of like the post office, okay? You have a standard address format when you send a letter through the post office. And that means that the mailman can pick it up and he takes it to the central post office and they look at the address and they load it onto a truck and it's delivered to a house and someone can open it, receive it in a mailbox, and they open it up and see what's inside and then they put it away. Okay, so this kind of standard chain of events means that anybody can send anything anywhere. Okay, and that's Ethernet. Works really, really well. The problem is there's a lot of steps in that process and those things take time. So when you're trying to do this image processing, and I'm not talking about displaying an image, I'm talking about real video workloads. So if you want to use your camera to identify an object in the road, to at the same time see all the cars around you, And to determine what to do with that, you need something that's very, very efficient and an order of magnitude faster. And the amount of data you're processing, as you said, with each camera is, it could be 6 gigabits, could be 12 gigabits for a 4K camera. And what if there's 10 of those, right? So now all of a sudden you've got 100 gigabits of data that you need to move real time. So PCIe is actually designed to work between these processors. And the analogy I use there is it's more like a direct delivery. So you don't go through the post office, you call the manufacturer and you tell them I need flour, and then you go to the closet and you get the flour out of the bin because the manufacturer has the key to the back door and he puts it in, he puts it not just in the closet, in the bin, in the closet where it goes, because you know that when you need flour, you go to that bin. Yeah. And so, okay, my analogy's, maybe a little simplified, but PCIe has a capability to do things called memory-to-memory movement. And this means that when a processor says, go get me this data and put it here, it no longer has to intervene. The switch, the switching technology takes care of everything. And so it really makes it efficient for big data movement and real-time video processing, whether it's video stitching or image recognition or video encoding. Those things take PCIe. And if you want to do software-defined networks, you need this high-performance cluster. It's going to include PCIe.
Okay, so a design engineer, at this point will likely need PCIe in addition to Ethernet, and it's a trading off the specific advantages of each protocol.
It's exactly true, and the data center guys, after 20 years of working on this, or 30 years of development, have realized that optimizing networks is not just performance enhancing, it's cost efficient, okay? And you'll realize a cost benefit when you put the right technologies in place to be able to process the workloads you need to process in advance, and then use software to determine what those how those workloads are processed.
Okay, so what is the latest from Microchip that a design engineer might want to be up to date on as far as Ethernet and PCIe?
Microchip is actually a leading provider of both those technologies, and what you'll see is significant developments in both. Ethernet can be seen on the website easily, lots of new products. We talked today about the need to add PCIe to the vehicle to support this software-defined networking. So if you go to the website, you'll find parts like PM40028, for example, represents a family of Gen 4 PCIe switches. This family is automotive qualified, supports automotive safety needs, and there's just a lot of investment in this area. So take a look at the website. You'll see, a range of lane sizes and bandwidths and technologies moving forward that support automotive needs.
Great. Fantastic. Thanks so much for sharing your knowledge about this.
You bet.
At this point, let's go to Aaliyah in the booth. Aaliyah, are there questions from our audience today?
Yes, Eric, we do. I have a question that we received on LinkedIn, and it is, how is Microchip looking at IoT in the automotive domain, and how is Microchip pitching there?
So IoT and automotive, in many ways, we think of an automobile as an endpoint, right? So it's an edge processing element where often IoT, we think of as little devices, sensors that go in your house. But essentially, if you talk about edge processing, an automobile is becoming a little data center on wheels, and it becomes an endpoint of the network that can do processing all by itself. Within that, you could argue there are little IoT functions, whether they be sensors or entertainment units connected by wireless to the network. So lots of activity. It's kind of a broad question, but lots and lots of devices that support that, from imaging sensors to position sensors to connectivity technologies, and of course processing elements all through the network.
Yeah. Okay.
Awesome. Thank you, Daniel. I have another question for you that we received from our email, and that is, if cars today can already deliver driver assist features, isn't PCIe just a fancy way of doing something I can already do?
So that's an important question. And I get this question a lot. Look, we already have it, right? We have lane centering. We have driver assist features already in our car. We're watching to make sure you're awake. Why do I need this new technology? And the answer really lies in the expectation of consumers, right? You have this range of driver assist expectations, from help me keep my car in the lane all the way to complete autonomous driving. And the real difference here is the kind of data you're going to process, how much data and the kind of data you're going to process. So if you're going to identify that there's something in the road and you expect your car to react, you're now going to process gigabits or even gigabytes per second of data, right? You have to take an image from a camera. You have to do image recognition. You have to take your radar data and marry it with your camera data to see if you trust that the two are saying the same thing. And then you have to make a decision. And all this has to happen fast enough for you to be able to respond and stop this 4,000-pound vehicle going 60 miles down the road, 60 miles an hour. And this is where PCIe really shines, is in addressing this bandwidth capability. And you'll find that in a dollars per bandwidth situation, PCIe in many times is actually cheaper to move bandwidth and move data than Ethernet. And that's contrary to most people's expectations, so it's important.
Okay, great. Second question is, if PCIe comes from data centers, can it also support safety critical applications?
Good question. So you'll see an effort across the industry, not just OEMs and their tier 1 suppliers, but also all of the component suppliers like Microchip, semiconductor suppliers. And this effort is around enhanced safety. In the past, we set a standard for automotive qualifications, and that was really focused on reliability of the components. But safety requires that you understand, if a part fails, how do I know it fails and how do I react to that failure? So increasingly, and we can say going forward, virtually all of the automotive products in Microchip will be functional safety compliant. Many of them will have ASIL ratings, so that the hardware and software is determined to be developed in a methodology where we prove that what is supposed to work really does work. And then we have monitors built into products that allow the system to know that the part is working properly. In the case of a switch, that the data did go from one port to another port without being corrupted. And if the switch has a problem, that in fact we supply information to the processor to tell it so that it can make a decision about what to do. Do I resend the data or do I shut the system down safely? Right. So you'll see this going forward a lot. Huge investment in Microchip in this area in support of the OEM needs.
Thank you, Daniel. I have another question for you that we got from our email, and that is, if I can just use my phone for audio, how does software-defined networking make any sense in a car? Isn't a light always just on or off?
So that's an interesting question too. It used to be that lights did just turn on and off. Now lights dim and lights move, and a light might go up or down, and when you're turning a corner at night, maybe the light shines over on the right or over on the left. So actually the answer these days is no, the light doesn't just go on and off. You have the ability to add features assuming there's a hardware platform that can support them. Okay, and this is something we're going to see increasingly in vehicles. It's one of those things that, what if you could send the manufacturer $100 and have your lights auto dim? Okay, would that be interesting? What if it was $10? Would that be interesting? What if you could have things like corner lighting and adjustable lighting as you go around turns at night? So those are features that manufacturers may choose to offer as downloads through a wireless connection, or you may be able to subscribe to a set of features where you pay $10 a month, and maybe now you've got adaptive cruise control that your car didn't have before, or you've got lane centering along with your adaptive cruise control. So the ability to add features, that's really what software-defined networking brings, is the ability to provide upgrades and changes. And by the way, how many of us get tired of getting a little notice in the mail that says there's been a safety recall, bring your car down so we can load some new software? Why do I got to bring my car down? If I have a telematics unit and I can receive from the network, just install it in my home, right? So.
Yep.
Great. And I can ask one more question. I think we have a little bit more time. And this is from LinkedIn. When will Microchip upgrade from the PIC AVR microcontrollers to a precise SoC-based philosophy?
Oh, that's a very technical question for my colleagues in the MCU organization. I'll answer in broad terms, okay? So we offer a range of PIC microcontrollers, PICs 8s, 16s, 32s, especially in the higher performance processors, you're seeing a range of upgrades. For example, the MCU 32 guys have just offered an ASIL rating in their processors with full functional safety compliance. It's not an exact alignment with the question you're answering, but it's an example of how we're changing the processor to meet the needs of the automotive customers. As far as an SoC philosophy, that's something you'll probably want to go to the website or contact your Microchip, local Microchip rep to talk about, because it's going to depend on exactly what you're looking for. We do offer RISC-based technologies that are going in some very specific applications. You know, I heard of one recently, a very big award that hasn't been publicly announced yet, but this is a RISC-based architecture, and it's very much designed around an SoC philosophy. We see the FPGA group implementing these kinds of things. We also see the MPU groups implementing SoC-based products. So I can't give you more specific details than that in this particular forum, but please reach out to someone at Microchip or contact us through the links you know, in any of the social media and let us know how we can help.
Thank you, Daniel, for answering our audience's questions today. If you have additional questions or comments, you can email us at livestream@microchip.com. Thank you, everyone. Back to you, Eric.
Thanks, Aaliyah. Thank you again, Daniel, for joining us
You
today
bet.
and
Thanks for having me. It was
sharing
good.
some of your knowledge. Great discussion. And thank you also to our audience for taking some time out of your day to learn about this topic. Please visit us at microchip.com/coffeebreak. There you can see our calendar of upcoming seasons for the rest of season 9. You have a variety of subscriptions and notifications you can sign up for, and you can also peruse our library of previously recorded episodes. So thank you again for your time, and see you next time.